All right, here's my fifth and final video from section 4 of the redesign practice test 2 in the calculator section. So in this video, I will handle questions 31 through 38, which are the ones that are not multiple choice. In prior videos, I did 1 through 10 here, 11 through 20. Probably could pause this while I scroll down. 21 through 25, and then 26 through 30, because they were taking a little bit longer towards the end here. And so I'll pick up with 31 here. 31, a coastal geologist estimates that a certain country's beaches are eroding at a rate of 1.5 feet per year. How long will it take for them to erode 21 feet? The way I like to think about these is 1.5 feet happens in 1 year. I don't like the decimals, so how about 3 feet happens in 2 years? If 3 feet happens in 2 years, how many years will it take for it to be 21 feet? Well, to change this 3 into a 21, I have to multiply by 7. So I would have to multiply this 2 by a 7 to get 14 years. You can set these up as ratios as well. You could say 1.5 feet per 1 year equals 21 feet in how many years? You set it up this way and solve, and you'll get 14 as well. 32, if x hours and 30 minutes is equal to 450 minutes, what is the value of h? Sorry, h hours and 30 minutes. Okay, I don't like this and 30 minutes. How about we just say then h hours, it doesn't say hours, h hours is equal to, if I subtract 30 over here, I better subtract 30 over here, 420 minutes. Right? If h and 30 more is 450, then h is 420. H hours is 420 minutes. I know there's 60 minutes in an hour. I guess I would need 7 hours. So, I don't know, h equals 7, I guess is the point that I'm trying to make here. 33, in the xy plane, the point 36 lies on the graph of this function. What is the value of b? If this point lies on the function, what that means is that when x equals 3, f of x, the y coordinate, equals 6. So I can just plug in. I got 6 equals 3 times 3 squared minus b times 3 plus 12. So I got 6 is equal to 27, 9 times 3 more, minus 3b plus 12. So I got that 6 is equal to 39 minus 3b. So if I add the 3b over to this side, I get that 3b is equal to 33 if I subtract 6 from both sides. And therefore b would be equal to 11. 34, in one semester, Doug and Laura spent a combined 250 hours in the tutoring lab. Doug spent 40 more than Laura. So what I like to do is to model this as a system of linear equations. Doug and Laura spent a total of 250 hours in the tutoring lab. Doug spent 40 more hours than Laura did. In other words, Doug equals Laura plus 40. So I have these two equations right here. You can solve a system of linear equations by adding the equations or by substitution. I think in this case it might be just as easy to do substitution. Let's see, it's asking me how many hours did Laura spend in the lab, which is nice. I'd get rid of the d's if it's asking me to solve for L. So to get rid of the d's, I'll have to initially solve one of my two equations for d. This one's already solved for d. So I'll take this first equation, and everywhere I see a d, I'll instead write L plus 40. So I got L plus 40 plus L equals 250. So then I got 2L plus 40 equals 250. So 2L equals 210. So L equals 105. So it looks like Laura spent 105 hours in the lab. If you're not confident in your answer, figure out how many Doug spent. Well, he spent 40 more than Laura. He spent 145. Does that check out? If you add up those two numbers, do you get the 250 total? Yep, you sure do. Cool, so we're feeling good about that answer. 35. We got a linear equation here. A equals 18t plus 15, where A is the amount of dollars that Jane has deposited after T weekly deposits. So the idea is she starts out with 15 bucks and then she puts 18 more dollars in every single week. According to the model, how many dollars was Jane's initial deposit? Okay, so all this is asking you is what is A when T equals 0, which you can get by plugging in t and solving to get the 15, or by understanding what these coefficients mean. This is how much he starts out with. This is how much a increases by every time t increases by 1. My answer would be 15. 36, in the figure above, O is the center of a circle. Line segments LM and MN are tangent. This line and this line are tangent to the circle. And the segments intersect at point M as shown. If the circumference of the circle all the way around is 96, what is the length of this arc LN? It's this arc length right here. Well, we could figure this out if we just knew this angle measure here. We can figure out this angle measure because I have a quadrilateral, a four-sided shape here, and the sum of the interior angles in a four-sided shape are always 360. And you're like, okay, so you're using up 60 here, but what about the rest of them? Well, because these lines are tangent to my circle, it means these are both right angles, right? If they're tangent, that means it just kind of touches at that point. If you were to extend this line, maybe it's easier to see that these two lines have to be perpendicular, that this is a right angle. So I use up 90 here, 60 here. I have 360 total to play with, and I'm getting rid of 60 and then 90 twice. 300 minus 180, that leaves me with 120, which is this angle measure right here. 120 is a third of 360. So really this arc right here is 1/3 of the way around the circle. All the way around the circle is 96. So if I take 1/3 of 96, which will give me 32, that would be my answer. If you have trouble with this 1/3 really came from 120 degrees divided by the 360 that's all the way around the circle, the 120 being this illegible number right there. 37 and 38 rely on this formula. It's kind of a fun, I shouldn't say fun on test prep, kind of an interesting formula. It defines n, the number of plants, recursively. So it says the number you have next year is the same as what you have this year, plus a little bit more than what you had this year times this factor right here, which is also dependent on this year. And the constant k is the number of plants the environment is able to support, this k right here. So what 37 tells you is that k is 400, and what it's asking you is what is the number of plants 2 years from now. K equals 4,000, and if you read this, we currently have 3,000. So this n this year, which shows up 3 different times in this equation, will be this 3,000, and then this 4,000 will go in right here. And I want to know 2 years from now. So I don't know, maybe n1 is equal to n0 plus 0.2 n0 times 1 minus n0 divided by, whoops, the minus is down here, n0 divided by k. So if I plug in, I got 3,000 plus 0.2 times 3,000 times 1 minus 3,000 over 4,000. And this will give me n1, the number of plants next year. So I get 3,000 plus 0.2 times, this is what, 3/4. 1 minus 3/4 is 1/4. So maybe I'll pull out a calculator since you're allowed them on this part. So I got 0.2 times 3,000 times, if you work this out, I think you'll see that it's equal to 0.25. So this entire term is 150. So what I get is that n1 is equal to 3150. But that's not my answer. I want to know n2. So to figure out n2, I take n1, this 3150, and to that I add 0.2 times this 3150 times 1 minus this 3150 over this 4,000. Okay, plug this into a calculator is probably easiest. I got 3150 plus 0.2 times 3150 times 1 minus 3150 divided by 4,000. Hit enter. Out pops this number, 3283.875. which is odd for plants. Let's see, what would be the number of plants 2 years from now? Round your answer to the nearest whole number. So what I would put in is 3284. That's my answer over here. Okay, what about 38? The botanist would like to increase the number of plants that the environment can support so that the population of the species will increase more rapidly. If the botanist's goal is that the number of plants will increase from 3,000 this year to 3,360 next year, so I got 3,360 equals 3,000 plus 0.2 times 3,000 times 1 minus 3,000 divided by K. How many plants must the modified environment support? Recall that K is the number of plants that the environment is able to support. So really what this problem is saying is solve this mess right here for K. Well, to get this K all by itself, maybe I'll get rid of this 3,000 first. That gives me 360 is equal to 0.2 times 3,000. I'm going to go ahead and call that the 600 that it's equal to, just to kind of clean things up. So really what I'm asked, well, let's just go ahead and solve this. Divide both sides by 600, probably be easiest. So you get 360 divided by 600. That 0.6 equals 1 minus this 3,000 over K. So if you add this over to this side and subtract 0.6 from both sides of the equation, you'll get that this 3,000 over K must be equal to 1 minus 0.6, aka 0.4. Multiply the K up to this side, divide the 0.4 down to this side, and you'll get that K is 3,000 divided by 0.4, which is 7,500, which is a pretty big number. That's a pretty large increase over what we had before. A reasonableness check. In 1 year, if I started with 3,000, after 1 year I had 3,150. Up here in 1 year, starting with 3,000, I want 3,360. So a lot more than this 3,150, more than double the increase that I had. In 1 year, I got 150 new plants before. Now in 1 year, I need 360 new plants, a lot more. So it makes sense that K is increasing by a lot, or at least it makes me feel a little bit better about that answer. And then you're done. You stop and you're done with this test, so that's all I will do here.